Hi students, welcome again to our Mathematics online classes. Today's lesson is to talk about the greatest common factor, GCF, greatest common factors of a pair of factors. We always talk about comparing pairs. Pairs means one and two, a couple of factors. Let's take in account 16 and 20. We have to see which could be the greatest factor for these guys. How many ways can we get 16? One way is multiplying 1 times 16. Another one is 2 times 8. Another one is 4 times 4. Is there another way? No, I think not. 20. 20, it could be found by multiplying 1 times 20. 2 times 10, 4 times 5. Is there another way? No. No hay otra forma de encontrar los factores que me den este número multiplicado. 1 por 16, 2 por 8, 4 por 4. No hay más. So, I have to see which are these factors. The first factor is 1. Here's 1. The second factor is 2. 2. The other factor is 4. The other factor is 8. And the other factor is 16. Now you have to see that I can put all these factors together, but I have to start from the smallest to the biggest. Tengo que empezar desde el más pequeño hasta el más grande. Empiezo el primero, que es el 1, el 2, el 4, el 8 y el 16. No hay más. For 20, my factors are 1, 2, 4, 5, 10, and 20. Okay. What are commons? 1, 2, 4. And that's it. They are not common. Which is the biggest? The biggest is 4. So the greatest common factor is 4. Very simple, right? So to get a greatest common factor of 16 and 20, we found it that it's 4. Let's take another pair. 6 and 12. How can I get 6? 1 times 6, 2 times 3. Is there any way? Other way? No. How about here? With 12. 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. So I have to remember that these are factors that should be multiplied. Now, which are the common factors? Here, 1, 2, 3, and 6. How about here? 1, 2, 3, 4, 6, and 12. Which are common? 1, 2, and 3, and that's it. And which is the biggest? 3. So the greatest common factor is 3. That's the way we find the greatest common factors of any pair that you may need to use. Okay? It's very important because we can work with fractions because we want to reduce them, make them smaller, make it not really smaller, but make it equivalent to the lowest term. Let's take in account 3 and 6. Well, 3 and 6 are divisible. If I divide 3 by 3, I'll get 1. If I divide 3 by 6, I get 2. So the equivalent fraction of 3 6 is 1/2. The same here. 6 eighths. Well, these are even numbers, so I can take half divided by 2. 6 divided by 2 gives me 3. 8 divided by 8 gives me 4. So the equivalent fraction in this case is 3/4. Again, if I get 3/15, I have to see if they are divisible. And the only number that could be divisible, it could be 3. And that's the only number because 1 and 6 makes 1 and 5 makes 6, which is divisible by 3. So 1/3 of 3 is 1. How many 3's are there in 15 So the equivalent term of 3/15 is 1/5. That means that I have to be very careful with divisibility. Which are the numbers that makes divisible by 2, by 3, by 4, by 5, by 6, etc. Until we get the prime number. So we have to remember the divisibility rules. Now we're going to remember what are proper fractions and what are improper fractions. Proper fractions are fractions whose numerator is smaller than the denominator. As you can see, 11 is small, 15 is bigger. 7 is smaller, 9 is bigger. So proper fractions are the ones that have a smaller denominator. An improper fraction on the opposite way is that the numerator is bigger than the denominator. As you can see, 7 is bigger than 5, as well as 9 bigger than 2, 15 bigger than 7. So these are improper fractions. Well, addition and subtraction work very interestingly when we have proper and common denominators. This is also a review of addition. Well, let's see. Common denominators, that means the denominator is the same. Here we have 15, 15. How do we add them? We only have to write the same denominator and only add numerators. 2 plus 4 makes 6, 6 plus 5 makes 11. So this is an addition of proper fraction. But what happens when they are improper fractions, but they have common denominator? Well, 3 halves is improper, 6 halves is improper, 7 halves are improper also. As you can see, the denominator is the same. So I add them. 3 plus 6 makes 9, 9 plus 7 is 16. Well, 16 and 2 are divisible, so I can reduce the terms. Half of 2 is 1, and half of 16 is 8. So my final answer is 8. Well, it's a nice way of doing it, but sometimes you may find another case. Here you have improper fractions, but also they have common denominator. If we add 6 plus 9 plus 8 plus 1, I get 24 divided by 7. This is an improper fraction as the answer, as a result. So I have to change it into a mixed number. How do I do it? I have to divide 24 by 7. If I remember well, 3 times 7 is 21. So 3 will be a whole number, and the remainder is going to be 3, because 24 minus 21 is 3, the remainder. So the answer will be 3 and 3/7. Well, again, we have to see if the denominators are similar, are common, are alike, and then we write the same denominator, and we add numerators. In this case, 4 plus 3 is 7, 7 plus 5 is 12, 12 plus 4, 16. Again, this is an improper fraction, so I have to change it into a mixed number. I can divide 16 by 3, and it's going to give me 5, and a reminder. So that means 3 times 15, 2 times 5 is 15, minus 16, 1 is remainder. So the final answer is going to be 5 1/3. Well, we continue with equivalent fractions. Well, as you can see here in this chart, we have this number, this whole number, divided in 4 parts. But from the 4 parts, 2 have been taken. So 2/4 represents this figure. In this figure, this part has been divided in 2, and 1 has been taken. But these fractions are equivalent, as you can see in the figure, because the green parts are equal. How can I know that these fractions are equivalent? I use a method of the cross multiplication. The cross multiplication method says that the product of the numerator times the denominator should be equal of the multiplication of the denominator times the numerator of the second fraction. This could be reflected here. If this is the number A and this is number B, A, numerator of A times denominator of B should be equal to the product of the denominator of A times the numerator of B. As we can see here, it's a cross multiplication. 2 times 2 is 4, and 4 times 1 is 4. And as you can see, both products are equal. If they are equal, then they are equivalent. Well, let's see what happens with these two fractions, 2/3 and 6/9. Well, we do the cross multiplication. Here, 2 times 9 is 18, and 3 times 6 is 18. Since both products are equal, these guys are equivalent. But not always could happen the same. 4 6 and 6/8. Let's check it. If I multiply 4 times 8, it's going to give me 32. And 6 times 6 is going to give me 36. As you can see, 32 is not equal to 36. Then they are not equivalent. That's the way we can find the equivalence between two fractions. And that's a very simple way of doing this type of exercises. Well, that's all for today. Wishing you a good day. Take care of you, and God bless you.